Hey everybody, Mr. Judson here. So we're going to go back to Chapter 5. We're done with things in Chapter 9. And we had just started Chapter 5 right before school was let out. We had just started Section 1. And one of the things we talked about was these trig identities. So let's review those real quick. All right, so these were the identities that we talked about. We started out with the reciprocal identities. Sine equals 1 over a cosecant of u. Cosine equals 1 over secant. Tangent 1 over cotangent, and so on. And then we also had our, they call these the quotient identities, but to me it's just tangent and cotangent. Tangent is equal to a sine over cosine. Cotangent is equal to cosine over sine. We had the Pythagorean identities. You guys remember these? Remember we did our little chicken scratch thing? We got these two by dividing everything here by either a sine squared of u or a cosine squared of u. One of them will give me this, the other will give me that second one. These were our cofunction identities, which when we talked about these, I said as long as these two angles add up to 90, we get the same answer for both of them. So like if this would have been the sine of 20 degrees and this was the cosine of 70 degrees, they equal the same thing. And we checked that on our calculator. You could do it again if you wanted to. And then we also had our negative angle identities, which this just means if I go in the negative direction, what I get is the opposite of the answer I'd get if this angle goes in the positive direction. Okay? So we're going to want to refer back to this now and then as we move forward in Chapter 5. Really the main thing that we want to get out of this first section is how do you simplify a trigonometric expression? And so first of all we need to talk about a couple of rules. And our rules are this. When we simplify this, we want to try to get down to one trig function if possible. You can't always do that. Sometimes we just won't be able to, but if we can, we want to try and do that. The second thing is we want no fractions if possible. For all these, we're going to say if possible. What I mean is, if my final answer is 1 over the cosine, well, instead of that, I'd rather say that's a secant. Okay? So no fractions if possible. Or 1 over a tangent, I'd rather just call that a cotangent. Okay? And our third condition is we want to try and get down to one term if possible. So something like, let's say I simplify this and I get to sine plus cosine. Well, that's two terms. There's no way to simplify that farther, and so sometimes we just can't. But if we can, we want to try and make these three things happen. I always say if you can't make three of them happen, make as many as possible. Maybe I can get one trig function and no fractions, but for some reason I just can't get down to one term. Maybe that's like a sine squared of x plus a sine of x. Those are all sine functions, but I can't get it to just a single term. Okay, so let's do this first one together. And I'm going to be honest with you guys. If I could tell you there's one thing that people don't like in trig, this is probably it. So maybe it's good that we do it now and just get it out of the way. Get this down to just one trig function without fractions and one term if it's possible to do that. And so when I look at this, the first thing I see is that there's a sine of x in each term. Now remember, a term is something that's being added or subtracted. So here's my first term, here's my second term, right? And so what I'm going to do is I'm going to factor a sine of x out of each of these terms. So if I do that, I get sine of x times cosine squared of x minus 1 And now when I look at this, this kind of makes me think of a Pythagorean identity. And so remember our chicken scratch? We got to think back a ways for this. But we would say sine squared plus cosine squared equals 1. If I've got a cosine squared of x minus 1, that means I need to move this 1 over to this side. It becomes the opposite. The sine squared will move over here and become the opposite. So what I see here is that a cosine squared minus 1 is really equal to a negative sine squared. Or a cosine squared of x minus 1 is equal to a negative sine squared of x. So what I have now is this. I've got a sine of x times a negative sine squared of x. And if I multiply those two together, I get a negative sine cubed of x. And so here, I have met all three of these conditions. I have only one trig function, there's no fractions, and there's only one term. And so we accomplish what we're looking for. I always tell people that this is really like a puzzle, and you kind of have to treat it that way. It's a puzzle, and we're just looking for the answer. I've got to step my way through this to be able to get that answer. Let's try another one. All right, so here's another problem. Let me have you guys go ahead and try this one. Remember, we're searching for one trig function at the end, no fractions, and one term. So what I'm going to do is I'm going to add some strategies here that I think are helpful on how to simplify this expression. And probably the most important strategy out there, and I think I've said this to you guys before, is if you don't know what to do, change to sines and cosines. Okay? Anytime you're not sure, change to sines and cosines. It doesn't mean that's always the best option, but it's always an option, and usually it's pretty helpful. All right, so if I look at this and I think, I don't know what to do, well, the strategy right here. Let's even put a star next to this. So if I change the sines and cosines, I know that a tangent is the same as sine over cosine. So we're going to say cosine beta times sine beta over cosine beta. And just one thing real quick, because this happens a lot. Sometimes students will get a little bit lazy and they'll just write cosine and then sine over cosine, and they won't include the angle. We have to make sure we include the angle, because a sine by itself or a cosine by itself, it really has no meaning. It's kind of like if I said to you guys, hey, what's the value of the cosine? You know, the first question you're going to ask me is, the cosine of what? There needs to be an angle in there. And I'll say, exactly. Yeah, we need to have an angle in there. So make sure that that's included as you write things down. All right, so when I look at this, I could think of this as cosine of beta over 1. Since that's in the numerator and that's in the denominator, they cancel. And again, really what we say when we cancel things is that a cosine beta divided by a cosine beta is equal to 1. And 1 times anything is the same thing. That's why we cross them out. And so now what I'm left with is just a sine of beta over 1, which I would just write like this. And there it is. I've simplified that. I've gotten this down to one trig function, no fractions, one term. Okay, let's try another one. All right, you guys go ahead and give this one a shot. So I'm gonna write down another strategy, because one of the first things I see when I look at this is there's an exponent of 2. And really this would apply to any even exponent. Whenever I see that, I want to think of one of those 3 Pythagorean identities that we just took a look at. So this will be another strategy. We'll call it number 5. If there is an even exponent, think Pythagorean identities. So when I look at this one, you know, I'm thinking in my head, sine squared plus cosine squared equals 1. I've got sine squared plus cosine squared equals 1. And what I want to know is, what can I turn this into? Well, if I move that sine squared over to this side of the equal sign, it becomes the opposite, it becomes negative. And so what I have is cosine squared equals 1 minus sine squared. So I could put a cosine squared of x in place of 1 minus sine squared of x. So now what I have is a secant squared of x times a cosine squared of x. If I go back to my strategy here, change the sines and cosines, this would be 1 over cosine squared of x times a cosine squared of x. Since one's in the numerator and one's in the denominator, I can cancel those, and I'm just left with 1. So when we say that this is our goal, to get down to one trig function, it doesn't mean that you have to have one there. It's okay to get down to just a number. You know, that would be fine. So this is now simplified. Now, somebody else may have done this a different way. Let's just take a look at another possibility. Let's say I looked at this and I thought, well, maybe I should distribute this. And so what I got is a secant squared of x minus secant squared of x times a sine squared of x. I would look at that and say, okay, that's true. Keep on going. And so then maybe somebody would get stuck and they would think, well, I'm going to change to sines and cosines. So I'll write this as 1 over cosine squared of x minus 1 over cosine squared of x times sine squared of x. This thing would really become sine squared over cosine squared. So sine squared of x over cosine squared of x, which really that's a tangent. Now I'm kind of going against what number 4 says, but if I look at this, this is a tangent squared, this is a secant squared, and someone might look at that and go, that looks like one of those Pythagorean identities. So again, I do my chicken scratch off to the side here. One of them says a tangent squared plus 1 is equal to a secant squared. So if I move that tangent to the other side of the equal sign, it becomes negative. And so now a secant squared minus a tangent squared is really equal to 1. And what I got is the same answer as the other one. Now, I know what some of you guys are thinking. You're looking at this going, oh, Judson, come on, that was way more work than needed. And I would agree. But I would also say what happened here is logical and makes sense. And if a student did this on a test, I would look at it and go, that's perfect. It's all makes sense. You got it right. You get full credit on that problem. So we need to think of this as, it's kind of like if I drove to the mall. There's a lot of different ways to get there. I can get on the freeway and go exit on 38th. I could go down Orchard and then turn on 56th and kind of work my way back. I could get on a Union and then there's a lot of different ways. There's a lot of different ways to get from here to here. It doesn't really matter how we get there as long as we get there. And I think that's a really important thing to remember when we're trying to simplify trig expressions. Okay? There will be a lot of these problems where there are multiple answers. Let's try another one. Okay, so here's another one. I've got sine theta over cosine theta plus cosine theta over sine theta. And so, if we go back and look at our goal to get one term or maybe just one trig function, I don't know, I've got fractions to start with. I'm not sure how this is going to work out. But the only way you can get down to one term is you need to get a common denominator and add these two together. So that's going to be another strategy, is when you have fractions, find a least common denominator and add fractions. So find least common denominator and add those fractions. All right, so we'll just go ahead and do this together because I know this is new to us. So if I'm going to do a least common denominator, I'll just say cosine theta times sine theta. That's my common denominator. And so to get that over here, I need to multiply top and bottom by a cosine theta. Remember, I want to multiply by a fraction that's equal to 1 because then I'm not changing the value of this thing. Even though it's going to look different, all I did was multiply by 1. It should be an equivalent expression. And over here, I'm going to multiply top and bottom by sine theta. Again, my fraction is equal to 1. I'm not changing the value, just the way that it looks. Okay, so now what I have is a sine squared of theta plus a cosine squared of theta over my common denominator. Sine theta, cosine theta. And so this looks a lot like a Pythagorean identity. Sine squared theta plus cosine squared theta is equal to 1. When I pause like that, I'm giving you guys a chance to maybe think in your head before I say the answer. Over sine theta, cosine theta. And I don't really think this can simplify any farther than this, other than I do think I can get rid of the fractions, but I'm not going to have just one trig function. I will have one term. I'm not adding or subtracting anything here, but I think I'm going to have two trig functions. I'm going to think of this as 1 over the sine of theta times 1 over the cosine of theta. And so to get rid of the fractions, I would call this a cosecant theta times a secant theta. So I wasn't able to reach all three of these goals, but I was able to reach two of them. I have no fractions and I have one term. We didn't get number 1, but that's okay. That's going to happen sometimes. The hardest question I think that students have here is, how do you know when to stop? How do you know when you got there? And that's a really hard question to answer. The only thing I can say is when we've met as many of these three conditions as possible. Okay? Always our goal right there. All right, let's try one more. All right, I'm gonna let you guys try this one on your own. We've got a tangent theta plus cotangent theta over tangent theta. Go ahead and try it. So I have a couple thoughts here. One thought is I could change everything to sines and cosines and see where I go from there. I'll try that one first. But another thought is I could separate this into two different fractions. Tangent theta over tangent theta plus cotangent theta over tangent theta. I'm not sure where either one of those is going to go, but we'll try it and see. Okay? So let's start by changing to sines and cosines. Sine theta over cosine theta plus cosine theta over sine theta divided by sine theta over cosine theta. So there's something that I've said to you guys quite a bit throughout first semester. Anytime you see a fraction within a fraction, that's called a complex fraction. And the best way to get rid of that is to multiply everything by the least common denominator. And that's what I see here. Now, could I get a common denominator and add these together first? And then just multiply by the reciprocal? Sure, I could. I could do that. Again, there's a lot of ways to get to the mall. We can take whatever way we want as long as we get there. Okay, so if somebody chose to get a common denominator and add these first, I don't see anything wrong with that. When you multiply by the least common denominator, what it does is it takes care of both of those things in one step. It adds these two together and it flips this over and multiply. So I think the least common denominator here is going to be a sine theta, cosine theta. Right? This factor is there, this factor is there, and this factor is there. That's our least common denominator. So I need to multiply every term by that least common denominator. So we'll do the same thing over here, sine theta, cosine theta, and we'll do the same thing right here, sine theta, cosine theta. So when I do that, in this first fraction, the two cosines cancel. I'm left with a sine theta times sine theta. That's sine squared theta. In this one, the sines cancel. That's plus a cosine squared theta. Here the cosines cancel, so I'm left with a sine squared theta. And now we should recognize that as a Pythagorean identity. So that would be 1 over a sine squared of theta, which is equal to a cosecant squared theta. And we've met all three conditions. I've got one trig function, no fractions, and one term. Now, let's go back and look at the same problem a different way. I told you my second thought was to think of this as the common denominator and divide this up into two different fractions. So what if I would have done that? Tangent theta over tangent theta plus cotangent theta over tangent theta. Well, that just equals 1. So I'm going to go ahead and do that. I'm not sure what this is equal to. So I think what I'll do is I'll change to sines and cosines. So I know a cotangent is cosine theta over sine theta. I'm going to divide that whole thing by a tangent, which is sine theta over cosine theta. And so when I flip this over and multiply, I get 1 plus, now you got to kind of picture this in your head, if I flip this bottom fraction over and multiply, I get cosine squared theta over sine squared theta, which is really a cotangent squared theta. And now I look at that and say, oh, that looks like a Pythagorean identity, and it's equal to a cosecant squared theta. So we got the same answer both ways. Two completely different procedures, but we both got to the same spot in the end. That's good. All right, so that's what we have for today. So I believe we are on number C7. This is getting hard for me to keep track of. It's page 379, and we're going to do 21 to 43 odd. And I did get some new information today about grading and kind of what's happening moving forward. And it's like I just saw it, so I'm not ready to pass it on yet, but that we'll address that the next time we meet. All right, you guys take care, stay safe.